Okay, continuing with 12.3, I split these up because I want to spend more time on this section. It's we're still talking about geometric sequences. A sub n equals a sub 1 times r to the n minus 1. And there's a question that says, two terms of a sequence are when a sub 3 is equal to negative 48, and a sub 6 is equal to 3072. So the third term is negative 48, and the sixth term is 3072. And then it says, find a rule for the nth term. So come up with some general equation for that. So the first thing is we're going to write two separate equations. We're going to write a system of equations using this. And that means we're going to have a sub 3 is equal to a sub 1 times r to the 3 minus 1. And we'll have a sub 6 equals a sub 1 times r to the 6 minus 1. So we already know that when the number is 3, a sub 3 equals negative 48, so we can plug that in. And when it's 6, the term is 3072. Okay, I'll just go ahead and clean those up. 3 minus 1 is 2. 6 minus 1 is 5. Okay. Now we need to solve this system of equations. The way to do this with exponents is going to be using substitution. So we're going to just go ahead and solve for a sub 1 and then plug that into the other one. So let's go ahead and do that for this one. So we're going to divide r squared on both sides. So we have a sub 1 equals negative 48 over r squared. And we're going to take that and plug it in to a sub 1 for the second equation. I know I'm running out of space, but I'll write it over here. 3072 equals, remember I'm substituting in, at this point we can cancel. We'll take these two away, take two of those away and change this to 3. So we have negative 48 times r cubed divide by negative 48 on both sides. Negative 64 equals r cubed. Take the cube root of both sides. So that's negative 64. I think there's a cube root button in math. Here it is. So math 4 is cube root. Negative 64. And we get negative 4. So the ratio is negative 4. The ratio is negative 4. Now that we know that the ratio is negative 4, we can plug that in to one of those two equations and solve for a sub 1, the first term, because we still need that. So we need to plug in negative 4. Let's just choose the first equation, this one. So negative 48 equals a sub 1 times negative 4 squared, 16. A sub 1 is equal to negative 3. Now that I have a sub 1 and r, I can write the general equation or the rule for the nth term. That's a sub n equals negative 3 times negative 4 to the n minus 1. That's the rule for the nth term. Of course, be very careful when you do this. I would just use lots of parentheses because you want negative 4, all of that to the n minus 1. not just the 4, you need the negative 4 as well. So now that we have this equation, we can solve for anything it tells us. Like if it tells us find a sub 14, all we're going to do is plug in 14 for n and see what a equals when n is 14. The last part of this section is to find the sum of a geometric series. And if you know you have a geometric series, you can find the sum of the first n terms by using this equation. Some of the things that you need to know are you need the first term, which is a sub 1. You're already aware of that. You need the ratio, and then you also need where you're stopping. So what's the last term in this series, for example? So let's go ahead and find the sum of the geometric series, this thing. It's 16 over sigma I equals 1, so 1 to 16 of this equation, 4 times 3 to the I minus 1 power. The first thing that we need to do is find the first term. So we're going to set up the equation a sub n equals a1 times r to the n minus 1. Remember, that's the general formula. We're always using that. And this equation is already in that formula for us. So it's actually a sub 1 equals 4 times 3 to the I minus 1. The only difference here is they use the letter I instead of n, but it's already in this formula for us. So if we want to find a sub 1, because we need that information, we say a sub 1 equals 4 times 3 to the 1 minus 1. We plug in 1 for I. 1 minus 1 is 0. 3 to the 0th power is 1. 4 times 1 is 4. So a sub 1 equals 4. So that's one piece of information that we have. Now, the common ratio, it already tells us r is 3. This equation is really nice. It tells us almost everything. It already tells us the common ratio is 3. So we're almost there. This geometric series wants us to go up to 16. So we'll set up the equation s sub 16 equals 4, that's a sub 1, times 1 minus 3 to the 16, all over 1 minus 3. We'll just have to simplify that. I think it's probably best to do these in parts, like 1 minus 3 to the 16th. We'll put that on top. So let's go with 1 minus 3 to the 16th, of course being very careful. Okay, divided by 1 minus 3, that's negative 2, times 4, and that's going to be our answer. So the sum of this series is 86,093,440. 86,093,440.